of x. I want you to make note of the little circle that's in the second notation. Is that fuzzy for you guys or just me? Fuzzy or clear? Clear, okay. Take a look at the little dot that's in there. What color is it? It's white. So we call that an open dot or a white dot. That's really important with composition functions because yesterday we looked at multiplication, and what color was that dot? Black. So a black or a closed dot is multiplication. An open dot or a white dot is called composition of functions. Okay, we're going to do it graphically and we're going to do it algebraically. So here's two different graphs just like yesterday. They've labeled f of x, they've labeled g of x, and they asked us to find a whole bunch of stuff. What kind of function is f of x? How do you know? Don't say straight line. Why does straight line bother me so much? Yeah, what's a non-straight line? So we can just say it's a line. That's how we know it's linear. What is g of x? It is square root. How do you know? Because of the swoop, right? Here is a whole bunch of instructions without using any words. Mathematically, this is saying, take the x value, put it into the g function, get some kind of answer out, take that answer and put it into the f function, and then you're done. This is a set of instructions that's telling you to do something. It's like 2 is our paper, g is telling you to fold it, f is telling you to throw it. So we always start with the inside function first. That notation is saying, go where x is 2. Jenna. Look at the g function. What's the y value? Offer of 1. I heard offer of 2 as well. So fight it out. 0. Okay, so now we got 3 possibilities. So again, this is saying go to where x is 2. Go to the g function. Tell me what y is. Okay, so y is equal to 1. So what this leaves us is now just f of 1, because g of 2 equaled 1. Well, this is telling you go to where x equals 1, go to the f of x function, and tell me what the y value is. 2. There's a composition of functions. It's just a set of instructions. It told you go to the g function where x is 2, figure out what y is. Take that answer, go to the f function, figure out what y is. Okay, let's look at the reverse g of f of x. So does it matter if we switch the order? Okay, we start with the inside function first, f of 2. What is that telling you to do? Yep, so go to 2. Go to the f of x function. What does y equal? Offer of 0. The second set of instructions is go to where x equals 0. Go to the g function. Undefined. And that's just like me giving you a set of instructions that's impossible for you to do. Okay, f of g of 1. Again, this is just a set of instructions without using the words, because mathematicians, we don't like words. Why do we not like words? But why? Why do we hate words so much? Why are we like, ugh, words? Yeah, because words are tied to language. So we have to speak English in order to understand English instructions. If you give this to any mathematician, any language they speak, they're going to understand what it means. That's why we love notation, because it's universal. What is this telling you to do? Go to where x is 1. Look at the g function. What is the y value? 0. That was step 1. What's the second set of instructions? Go to 0. Now this would have been great had the graph not gone off, so let's just extend it to where it might cross. Questions so far? Can I, pull it, yep. Let's do it algebraically. This time no value for x. We're just given f of g of x. What is this telling us to do? So what does it mean when there's no number there? Okay, so put x into g, then figure out what that is, and then put that into f. So if I put x into g, what do I end up with? The same function, x squared plus 2. So f of g of x is saying go to the f function, take out x, and I put brackets in x's place. And what am I going to put instead of x? X squared plus 2. So I am literally putting g of x into f of x. And then we would just simplify like we've been simplifying since grade 9. How do I get rid of the brackets? Just meh, what do we call that? Kind of. Distribute. Okay, so negative x squared minus 2, and then I still have that minus 5 hanging around. Confirm? What is B asking us to do? The opposite. Put f of x into g of x. So here's a trick for visual people. We want to go into g of x, so I'm going to circle that x. And I'm going to show f of x going into its place. We're putting f into g of x. So I'm keeping the squared and I'm keeping the plus 2. X is out. What's going in? Okay, so if putting the arrows and circling helps you, great, do it. If it doesn't, don't bother. Okay, negative x minus 5 squared. Can I just distribute the squared? So minus x squared is x squared and minus 5 squared is 25. Why not? Well, we distributed up here. Why can't I distribute here? Because I don't want to kill a kitten. No, we can't distribute an exponent. We can distribute a coefficient, but can we distribute an exponent? No. What do I do with this? Foil. And if you need to write it twice to see that, then write it twice to see that. Okay, so if that helps you to actually see it, great. So negative x times negative x. Negative x times negative 5. Negative 5 times negative x. And negative 5 times negative 5. And then don't forget this 2 that was hanging around at the back. How many x squareds do we have? How many x squareds do we have? How many x's do we have? And how many constants? There you go. There's g of f of x. Point of doing these was look at the difference with the order. So if we switch the order, does it matter? If we switch the order, does it matter? Yes, completely different answer. If you switch the order and you get out the exact same answer, what does that tell you about the original functions? So if you switch the order and they come out to be the exact same answer, what does it tell you about the original functions? Good guesses? So think about something we've done this year where we have switched the order of something. Who said it? Who said it? High five to you. Say it louder. It means they're inverse functions. Because if we flip the x and y, that's how we drew inverse functions. I'm just going to repeat that in case you want to make a note. If you switch the order of the composition, and the answers are the same, if you switch the order of the composition and the answers are the same, the two functions are inverses. Okay, see, we're back to putting a number. So if there's a number, we just do it like before. We start with the inside. What does f of negative 2 mean? Put negative 2 into f. So I'm going to take out x. I'm going to put in negative 2. Why do I have negative negative? Because there was a negative in the function, and there's a negative too, so we get negative, negative. Simplify it up. So that means now the question is asking for g of negative 3. What does that mean? Go to g, put in minus 3. Offer of 11? I agree. So just like yesterday, if there's a number in your answer, in the question, your answer is going to be a number. If there's x in the question, there's going to be x in your answers. F of x, what the heck is that? How can we put a function into itself? Okay, well, have you ever put bread into your toaster and you wait and it pops up but it's not toasty enough? What do? You put it back in. That's what this means. You're putting it into itself. So you put the bread in, pops up, not toasty enough, pops up, then usually it's burnt and then you have to start over. So this means we're putting f into itself. So I'm going to take out everything except the x. And what am I going to put in its place? The whole f of x function. There's a function into itself. Oh, minus 5, thank you. Okay, so it's just a set of instructions that they want you to do twice. Okay, distribute the negatives, going to give us x plus 5. So just x. That's kind of cool. We put in x and we get out x. That's like putting bread into the toaster twice and coming out with bread. Okay, let's do the same thing but with some rational functions, because we love rational functions. Biggest thing you want to stop and pause and make sure you have the notation in the right order. So you need to know, are you putting f into g or g into f? So what is this in the other notation that we've been using so far? So what would it look like if we put it in the other notation? What's on the outside? What's on the inside? So what would this look like in notation like this? F of g of x. So g is the inside function. So if you like the circle thing from before, that means we're going to f and we're taking x out. And what are we going to put into its place? All of g of x. Okay, there's f of g of x. Take x out of f, put in all g of x. Okay, we need to do some simplifying here. So this is really just like what we did with identities, fraction divided by fraction. No biggie, we can do it. Where do we start? Denominator, and what would you like to do on the bottom with the denominators? So first fraction isn't going to change. What's going to happen with this bottom fraction here? Offer of 2x minus 8. Confirm. Okay. Keep the one on the top. Now we're going to smush this all over one denominator. Offer of 3x minus 8. And the last step, how do we divide fractions? Flip it. Let's pretend the one's not there because we're going to multiply in the same step. Okay, so there's a composition of function with rational functions. Little note here, to find the domain of a composition of functions, you must look at the NPVs of the composition as well as the NPVs of the inside function. So to find the domain of a composition of functions, you have to look at the NPVs of the final and anything that was an inside function. So any general rational graph, the domain always starts with XER. But then we have to state what x cannot be. So if we look at the composition or the final answer, what can x not be? 8/3. So if we weren't doing a composition and this was just our question, we would be done. Because we're doing a composition, we also have to go back to the inside function, and we have to state any restriction from that one as well. So x cannot be 4. So there's our domain for the composition. XER, but x cannot be 8/3 because of this one, and 4 because of this one here. How are we doing? Because we replaced this x, so it's irrelevant once we simplified. Okay, let's do a radical. Given f of x is square root of x, and g of x is negative x squared plus 2x, determine g of f of x and state its domain. Let's name them. What kind of function? Radical. The official name would be quadratic, so rational and radical and quadratic. What's going into what? So the x's are going to come out of g, and what's going to go in their place? F. Again, if the circling and the arrows do nothing for you, then don't worry about it. So the negative's going to stay. Square root of x is going in. The squared is going to stay. Plus 2 is going to stay. And root of x is going in. Root of x squared. And then times negative 1. And then we're just going to add 2 root x. Can I add an x with a root of x? Nope. Keep it there. Domain. Okay, so what are the restrictions on this, which will also be the restriction on the inside function? So what is the restriction always with a radical function? X has to be greater than or equal to 0. Okay, so it just comes from the normal restriction on the radical. Last one, let's do an absolute value. Turn to someone, together figure out f of x, f of g of x, and g of f of x. Questions with the graphs? You'll often see the instructions on the exam. They'll ask you for a fully labeled graph. Fully labeled graph. What that means is you're just telling me which of these is which. So you're going to label this bottom one as g of f of x, and the top one is f of g of x. That's all they mean by fully labeled graph. Sometimes people go crazy and they start writing independent variable and dependent variable and x-axis and all these. No, that's all they want to know, is just that you know which function is which. It also helps to label because if your graph is wrong and we can't tell which is which, we can't give you any points. So it's always a good idea, even if the exam doesn't say, just to label the function so it's really clear for the marker. Domain and range. So let's do f of g of x first. Offer of negative infinity to infinity. No one confirming. Okay, range. Confirm. G of f of x. And the range. Confirm.